All right, practice test 3. Now, guys, what does the test look like? Yes, so let's make sure we got this all figured out. All right, practice test 3, number 1. How many outfits can I make if I have 10 jumpers, 12 shirts, and 2 pairs of shoes? What am I going to do? I gotta pick a jumper, and I have 10 choices, and I have to pick a shirt, and I have to pick a pair of shoes. So my answer is
440.
240.
Oh, my bad.
So there's 240. Now, how many ways can 8 people be seated around a campfire? 7 factorial, which we'll type in and get 5,040. Remember, around the campfire is 1 less, right? How many ways can you answer 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 multiple choice questions if each question has 3 options? So like A, B, C, I pick A, B, or C. So 3, 3, 3, 3, just like the jumper shirt problem. So what's the answer going to be? 59,049. That's exactly right. 59,049. Okay, now, probability of a 5-card hand. Okay, stop right there. What's your denominator? 52 C5. Now, on our last practice test, it was a 4-card hand. So what was the denominator? 52C4, right? Now, I want 4 hearts, exactly 4 hearts. So remember, it's a 5-card hand. So that means 4 hearts and 1 other card that's not a heart. All right, how do I get 4 hearts? 13C4. Where'd the 13 come from? 13 hearts. And I'm picking 4. And, so times, another card, 1 more card, that isn't a heart. Well, how many are there that aren't hearts? 39. And we want 1 of those. There's 13 hearts. So there's 13 diamonds, clubs, and spades. 13, 13, 13, that's where the 39 came from. Alright, these are the kind you really have to be on the lookout for scientific notation. I don't know if this one will be or not. No, this one actually came out .0107. Is that what you got? 5-card hand that has all face cards. So it's a probability again. So 52C5. Now, all face cards. What's that numerator going to look like?
12C5.
12C5. Where did the 12 come from? Jack, Queen, King, 4 suits. So 4 jacks, 4 queens, 4 kings. 12 cards. And that one is scientific notation. So 3.0473 times 10 to the -4. Alrighty? Okay, read the next one. What's our strategy here? How are we gonna do this one?
Circle.
Venn diagram. We got 80 kids. Some of them like matrices and some of them like vectors. So I have these 80 kids out here in the room. How many of you like matrices? And 48 say, yes, I do. Raise their hand. Say, okay, how many of you like vectors? And 42 raise their hand. Well, if 48 voted for matrices and 42 voted for vectors, how many kids voted? None. But I only have 80, so that means there must be 10 that are in overlap. Would you agree with that? Now, if the entire matrix ball is 48, but 10 of them are already in there, then these are 38. And likewise over here, these are 32. And then we can answer the question, which is, how many like only vectors? So that answer would be 32. How many committees of 5 Republicans and 3 Democrats can be chosen from a group of 10 and 7? So I have 10 Republicans total and 7 Democrats total. And I have to pick 5 Republicans and 3 Democrats. What do you think? Ava, you're typing away. What are you typing away back there?
It's 5C10.
Be careful. 10C5
Yep.
and 7C3, and they're times each other. Because we're picking 5 out of the Republican pile and 3 out of the Democrat pile. It is C because we don't care what order they're in. I got 88 20. Does that sound about right?
So you use P like when it's like coming first, second, third.
Yep. All right. How many ways can 4 students be lined up out in the hall? 4 factorial. 24. 4 factorial, or lining up things in a row. How many ways can I give 5 identical pencils to 5 students in a class of 8? 8C5. 8C5. When would it be P? If I was giving away a pencil, a marker, an eraser, different presents. Different presents, make it P. Identical things, keep it C. How many 10-letter words can be formed from the letters of calculator? All right, so we got 10 letters. So we start with 10 factorial. And then what are we gonna divide by? 2 C's, 2 L's, 2 A's, and that's it. So when we do this, We divide, divide, divide. Everybody remember that? 453,600 is what I came up with. Alright, now we have to do the homework problem. What's our strategy for this guy? Tree diagram. Ultimately, I want to know what's the probability that Tim will do homework. So bottom is going to be homework, no homework, homework, no homework. Because whatever the question is, that's what goes on the bottom of your tree diagram. Then we have rain and no rain. All right. If it rains, the probability he'll do his homework is 0.65, which automatically means this one is 0.35. If it doesn't rain, the probability is 0.32, which makes this one 0.68. There is a 10% chance of rain. And we want to find the total probability that we do his homework. So what do? We get our calculators and what do?
So 10 and 16.
Multiply these. Guys, everybody multiplying. Rain and homework, we multiply. And then not rain and homework, we multiply again. And then we got an answer when we multiply here. We got an answer when we multiply here. What do we do with those two answers? And get 0.353. Everybody good? Were you able to recognize that that was a tree diagram problem? When you read the problem, did you think about doing that? That's what you have to do tomorrow, or Wednesday. Okay, expand 3x minus y to the 5th power. What do we do first? Where do we start? We gotta have Pascal's triangle, because we start with the numbers. We write down what are my coefficients going to be. So my triangle and I need to go down to the 5th row because of this right here. You gotta be able to build that on your own. If you're gonna use it, you gotta be able to build it. I told you when we first started doing this though, you can generate these numbers a different way. The other way is 5C5, 5C4, 5C3, 5C2, 5C1, 5C2. Those are the numbers. Those are 1, 5, 10, 10, 5, 1. You can always get them using the combination numbers. 5th row, 5C5, and then count down. All right, so anyhow, I've got 1, 5, I'm gonna erase this now, because I need all this space.
So can you do that if it was like 7 too?
Yep, works for everything. There are my coefficients. That's the 5th row, Pascal's triangle. I'm giving myself plenty of room all the way across the page. There's no sense in packing it in because there's a lot more stuff I need to write down. What comes next after I write down all those numbers?
Fill in.
I put a 3x and a negative y next to everything. In parentheses, 3x, negative y, all the way down the line. Where did the 3x and the negative y come from? The problem. Now what? I'm missing something. I'm missing my exponents. So I remember that if I FOILed this out, the first power on the first term, the 3x, would be 5. That's the first power on the 3x. So then this one will be 4, 3, 2, 1, 0. Anything to the 0 is 1, so I'm just gonna kind of mark that out right now. And then what about the y's? Same thing, other direction. And there's another 0, so we'll cross that one out. And then to keep it all straight, I'll just put plus signs between everything. And now I will simplify each term. So, what do I got here? No! 243 x to the 5th. Guys, we have talked about this. This is a trap. And if you're not awake, you're going to fall for it. See that parentheses to the 5th power? What does that mean? 3 to the 5th, x to the 5th. They both get the 5th. They always will. Here, they're both going to get the 4th. So here we have a 5. We have an 81 x to the 4th. And that's like a negative 1. Why? It is not a subtraction, it is a multiplication. Everything there is getting multiplied. So what's 5 times 81 times negative 1?
Negative 405.
Negative 405. X to the 4th, y. What am I multiplying here? A 10. The entire thing is getting cubed. 27 x cubed. Guys, it's so easy to pay attention because you're going to miss these points. That's silly. And then this would be a negative squared, so it will become positive.
Yeah.
So 10 times 27 times 1 would be 270 x cubed y squared. All right, let's try it one more time. What's this?
90.
Not, well, this part is just 9x squared. Now here's a negative to the 3rd. That stays negative 1, doesn't it? So it's actually negative 90 x squared y cubed. This is 3x. And what happens when we take a negative to the fourth power? Positive. So plus 15x y to the fourth. And then finally, all we have down here is a negative y raised to the fifth. Is that gonna be positive or negative?
Negative.
Negative y to the fifth. When you raise a negative to an odd power, it's negative. Okay? Now, 13 is the same, except luckily, we don't have to do the entire problem. We are only looking for the third term. So it would be like looking for this. So every term, think back, when we first started this problem, every term, we started by writing down our coefficients, right? So I need a coefficient for this. Now you have a choice, it's completely up to you. If you're gonna use Pascal's triangle, you're gonna have to write it out to the 10th row. Or you can remember what I told you about the combination numbers. In Pascal's triangle, the first number in the 10th row would be 10C10. And what would the second number be? 10C9. And the third number would be 10C8. And that's the one I want. I want 10C8. Is that 45? If you wrote out Pascal's triangle all the way to the 10th row, the third number in that row would be 45. It works either way. Now, next, once I wrote down my numbers up here, I put a 2x and a negative 3y. The two parts of the problem go here. And then what's the only thing left to do? Exponents. Now, if I wrote out the whole thing, there'd be a whole bunch of them. In the first term, what would the power on the 2x be? In the first term, it would be 10. In the second term, it would be 9. And in the third term, the one I want, it is 8. No magic, I counted. And then, if that's an 8, this one's got to be a 2, because they got the powers, have to add up to 10. All right, so what am I multiplying? I'm multiplying 45 times what? What's this? 256 x to the 8. What's this? 9y squared. So I'm gonna multiply 45 whoa, I got 103,680 x to the 8 y squared.
Where did the 45 from?
It's the third number in the 10th row of Pascal's triangle.
Oh,
10C8. You gotta start with, you gotta get your numbers, 1, 5, 10, 10, 5, 1, you gotta get those numbers, but this time it's the 10th row.
I don't know, I got it from the 5th or 6th.
Okay? How do you calculate 8C5 by hand? 8C5 by hand. How do we do that? Got a little formula for it. Who remembers? 8 factorial goes on top. What goes on the bottom? 5 and 3. Remember with the C's, you have 2 things on the bottom. That number and then the difference number. So then you gotta write out 8 times 7 times 6. And what happens after 6?
Just cancel it.
You get 5, 4, 3, 2, 1. You still have 3 times 2 times 1, which is 6. So the answer is 56. I feel like we've done that one before. If you want full credit on that problem, you have got to keep going by hand until the denominator is all gone. As soon as the denominator is all gone, then if you need to multiply that on your calculator, that's sad, but fine. But you gotta have your denominator gone before you go to the calculator. All right, number 15, we have a Venn diagram. And we know the probability of M is 0.62 and the probability of N is 0.75. And what does this mean right here? What does that mean? And yeah, so that's, we like, I don't know, what starts with M and N? We like money and numbers. We like money and numbers. Where does that go in my picture? That's right here, isn't it? And if we put 51% of our people right here in the middle, how much does that leave to be over here in just money? 0.11. And how about numbers? How much here? 0.24. What do these add up to?
Yeah,
0.86. So what does that mean? That's 86% of the people are in there, which means there's 14 out here. And who are those 14 people? They don't like money or numbers. And actually, isn't that question B? We don't like money and we don't like numbers, question B. That would be 0.14. What's question A?
Money, no numbers.
We like money, but not numbers. So that's your 0.11.
And you want us putting that in as a decimal, not a
Doesn't
percentage?
make any one bit of difference. Decimals, fractions, percent. Whatever, doesn't make any difference. All right, last one. Now we've got our tables of kids. And I think all the numbers are the same as before, but now we're asking different questions. Both like English. So English and English. So what'll that be? 0.2 times 0.3. 0.06? First likes math, and second likes art. Alright, so probability of first kid liking math is 0.6. And second kid likes art is 0.06 again. Nobody likes science. So the probability of not science and not science. Alright, so here we go. Class 1, what's the probability we don't like science? 0.9. And class 2, we don't like science. 0.8. So 0.72 for that one. And then we want science and math. tricky about this one.
Doesn't say which part.
It doesn't say who's who, right? So I could have first science and second math, or I could have first math and second science. Does everybody see that in the problem? All right, so I can do both. All right, so first science and math, 0.04. And then math and science, 0.12. Since it could be either one, could be this or this, what do I do with those two numbers? Oh,
Add and then divide by 2.
add and then divide by 2, okay. Guys, when it's this or this, you add 0.16. 0.16. We've done that every single time. When it's this or this, we add.
Could you do? Does it matter if you do 0.1 times 0.6 or like?
Oh, that's a 0.2.
I know, but if you just switch 0.1 to 0.2.
No, this is class 1, and this is class 2.
Okay, so you have to do.
Yeah,
You can have
you're picking one from each class. Okay?
Yeah.
Now, I have some more practice for us to do. Get over here. So it's not a full practice test. You already have 3 of those. Sweetheart. Well, take a picture of it. Take a picture of it right now while it's going. All right, here we go. Expand x minus 2y to the 4th power. Well, this looks an awful lot like what we just did. So what's step 1? I need the 4th row of the triangle, right? Now, I already wrote it out. I'm old and do this all the time. I have the 4th row memorized. What is your other option if you don't want to use the triangle? You can do 4C4, 4C3, 4C2, da da da. That will give you the same numbers. All right, what happens next? Next to each of those, in parentheses, we put an x and a negative 2y. Right? Now what? Exponents. And right here, first term, first exponent is going to be 4. And they're going to count down. And when I get to 0, I'll just get rid of it. And then the y's do the same thing on the other end. And there's another 0, so get rid of that one. And then we'll put plus signs in between because we know we're going to have to simplify each term individually. Here we go. Easy one to start. What's this one? Just x to the fourth. Alright, what am I multiplying here? I have a 4, an x cubed, and a negative 2y. So what does that make?
Negative 8 x to the third.
Yep, perfect. Alright, how about here? I got a 6, x squared. Oh, I hesitate to ask, what is this? Yes, 4y squared. Positive, because a negative times a negative is a positive, right? Remember, you have a calculator, so if you really can't do this without, type it in. So we have 24 x squared y squared. Okay, what have I got here? 4 x, and what's that? Negative 8y cubed, and that's times. So negative 32 xy cubed. And then what's on the end?
16y.
Plus 16y to the fourth. Negative to the fourth power would be positive. Good, good, good. Fifth term of 2x plus 3y to the 7th. I do not have the 7th row memorized, and I really don't want to write it all out and figure it out. So what's my other way of finding the numbers if I don't want to do the triangle? 7C7 would be the first one. I want the fifth one. So this is 7C7, 6, 5, 4, 3. So 7C3 will be my number. First one, 7C7, 7C6, 5, 4, 3, fifth number. And what is that?
35.
What is it? 35. 35? Next to the 35 is going to go a 2x and a 3y. Now, if I'd started at the beginning, the power on the 2x would be 7. So the first term, it would be 2x to the 7. 6, 5, 4, 3 again. So this is a 3. And if that's a 3, then this one's got to be a 4, because they have to add up to 7. So what am I multiplying? 35. What's this guy?
8.
8x to the third. What's this one? 81 y to the fourth. So I have to multiply 35 times 8 times 81. So 22680 x cubed y to the fourth is the term done.
Why do you use 7C3? 7C.
The first term is 7C7. The second term is 7C6. I simply count. All right, I have a committee. I have 10 Republicans and 16 Democrats, and I need to choose 2 Republicans and 3 Democrats to be on my committee. We just did one exactly like this. What do we do? C2, that's how I pick my Republicans, and 16C3, that's how I pick my Democrats. got 25,200. Does that sound right to everybody? All right, probability of getting 2 diamonds and 3 clubs. 52C5 is your denominator. It's 5-card hand. Now, my numerator, I want 2 diamonds. How do I get 2 diamonds? 13C2. 13 diamonds. And, so times, and 3 clubs. 13C3. 13 clubs, I'm picking 3 of them. I got .00858. These are the ones that can definitely come up in scientific notation, so be careful. What, Jack?
It's always 13 for the club.
That's how many clubs are in the deck. That never changes. If I'm asking for face cards, it might be 13. Because there's not that, there are 12 face cards in the deck. All right, how many ways can the letters of We Love Math be arranged? So what do we do first? Count them up. 10 factorial. We start with 10 factorial because that's how many letters there are. All right? And then we're going to divide by anything we have duplicates of. So I see 2 E's. Do you see anything? Okay. Remember, if there'd been 3 T's, I would divide by 3 factorial too, right? I divide by whatever I've got. This one's, that's it. Uh, 1814400. So 1,814,400. HC3 by hand. We actually just did this one. So let me change that. Let's make it 8C4. Let's do 8C4 by hand. Because we just did 8C3. I know what some of you might be thinking. I don't know if any of you are paying that close attention. But what we did on the practice test was 8C5. And this one is 8C3. And I'm telling you they're the same thing. Can you see that? Because when you do this, it's 8 factorial over 5 factorial, 3 factorial, right? What's this one gonna be? 8 factorial over 3 factorial, 5 factorial. See how they're the same thing? So we're gonna do this one. It's same idea, but it'll be a different number. All right, so here we go. What's the formula for 8C4?
8 factorial over 4 factorial.
Yep. So 8 factorial is 8 times 7 times 6 times 5. And then I can stop there because after the 5 will be 4, 3, 2, 1. That will cancel with one of those. And then I still have 4, 3, 2, 1, another 4 factorial on the bottom. So remember, you can't go to your calculator until you have canceled the denominator gone. It will always, the denominator will always be gone. You can always get rid of it. So I don't know, 4 and 2, that would take care of the 8. 3 goes into 6 twice. So what am I left with? 7, 2, and 5, so the answer is 70. What if that had been 8P4? What's the formula for 8P4? 8 factorial over 8 minus 4. So it's 8 factorial over 4 factorial, but it's not that 4. It's the 8 minus 4. In the P denominator, it's the subtraction number that goes down at the bottom. Okay. All right, number 7. There are 30 students in our class. 18. Now, I drew a Venn diagram. I will not do that on the test. Could you read that question and figure out or think, oh, I'm going to do a Venn diagram? You have to be able to do that because I won't draw the diagram on the test. So we have 30 kids in the class. Some of them like English, some of them like math. In fact, English there were 18 and math there were 20. What is the probability of choosing a student who only likes math? Everybody likes something, so there's nobody out here. All 30 are in the circles. All right, so what's your thought? What do you notice right off the bat?
It's more.
We had 38 votes and only 30 kids. So 8 of them are here. Which means, how many are here? 10. And how many are here? 12. Right now I've got all 30. I'm gonna reach in the box, 30 kids in this box, I'm gonna reach in and grab a kid out. What is the probability that he only likes math? How many kids only like math? 12? How many kids are there altogether? 30. So your answer is 12 over 30. I don't know, we can get a percent for that, or we can reduce the fraction. 4 tenths, 2/5. So did anybody say 0.40? Okay? All right, that takes care of that. All right, so you know what the test, and we just practiced it, some of it twice. Anybody want to do an extra problem of some kind? Josh, your hand up. Jack? All right, let's find the 4th term. 3x minus 2y. So what's the first thing I have to do? Find the number. I gotta figure out which coefficient is. So what are my options? I can write out the 6th row of the triangle down to the 6th row. Or I can remember that the 6th row numbers are 66, 65, 64, da 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 da. I want the 4th one, 66, 5, 4, 3. So 63 is my coefficient. Now, what's next to that coefficient? I'll figure out what that is in a minute, but what's next to it? A 3x and a negative 2y. Okay, now I need my exponents. If I did the whole thing, what would the first exponent be on my 3x? The first exponent would be 6. So the first one's 6, and then it goes down to 5, 4, 3. So the fourth term, just counting on my fingers, would make that a 3. And if that one's a 3, then so is this one, because they gotta add up to 6. So now I'll figure out what I've got. So that's 20. 27x cubed and negative 8y cubed. So I have to multiply 20 times 27 times negative 8. So negative 4320 x cubed y cubed would be the fourth term of that expansion. Alright? I have 8 kids. I have to pick a captain and a co-captain. How many ways can I do that? 8P2. Why is it a P? Because they have jobs. They have specific jobs. If I were picking a committee, it would be 8C2. Alright? I have 10 kids. How many ways can I seat them around the dining room table? 9 factorial, right? Whatever that is, 9 factorial. The word Anna. How many ways can I arrange the letters of the word Anna? Type it in on your calculator. I want to make sure everybody's typing it in right. Type it in. What'd you get? 6. 4 factorial divided by 2 factorial, 2 factorial? 6, perfect. If it's Monday, the probability Zach is on time is 20%. If it's not Monday, the probability is 30%. Find the probability Zach's on time. Okay? How are you going to do this problem? What is going to be your strategy? You're going to do a tree diagram. Everybody understand that? Do a tree diagram. And you're going to have, Monday, not Monday. You're going to have on time, not on time, on time, not on time. You're going to have 2 branches down here where he's on time. You're going to multiply the branches. You're going to take those 2 answers and add them together. All right. That's it. Test on Wednesday.